Hello, hi, my dear students. Today we are going to discuss a new topic from physics, okay? Because this topic is really important for the exam. That is why I am taking from in between. That is PN junction diode. Actually, this introduction part it is actually there in chemistry that we already discussed. That is semiconductors, extrinsic semiconductors, intrinsic semiconductors. In that it is coming little bit. That is p-type semiconductor, n-type semiconductor. Hope you remember that. Okay, so we can continue with what is this PN junction diode. Fine. Okay. So topic is PN junction diode. Okay. So here p-type semiconductor and n-type semiconductors are there. So when we join the semiconductors together, we will get PN junction diode. Fine. So we are going to join the p-type and n-type semiconductor. Okay. So you will get a PN junction. So here we can write P, here we can write N. So in here p-type semiconductors, majority charge carriers are holes, right? Majority charge carriers are holes. That is why positively charged, that is P. In between minority you can see electrons. And whereas in n-type, they are the majority charge carriers. It is what? Electrons, right? In n-type, that is negative. In n-type semiconductors, we are adding an impurity which is a pentavalent, right? And here in p-type, we are adding impurity, it is trivalent. So here one deficiency of electron will create a hole. Here one excess electron will be there, right? Okay, so in between the minority holes also you can see. So what happens first? So now this is a PN junction diode formation. P-type, N-type joining together, you will get PN junction diode. Fine. So here this electrons has, here holes are there, here electrons are there. So both have an attraction, right? So the electrons will go to this holes. And what happens? Electrons will diffuses to that holes. Okay, so first process happening this, it is called diffusion. Find these terms you cannot, because with these key points you can make the explanation. By expanding each point you can make, right? So what is happening first? Diffusion is happening, that is electrons from n-type diffuses to p-type holes. It diffuses to holes. Fine. So there happens, due to that movement of electrons, a small current produces. That is known as what? Diffusion current. That current is known as diffusion current. Fine. Okay. Now, next what happens? That is due to this diffusion process. Here charge carriers shortage will come. Here also respective charge carriers shortage will come. So what you can note the point? Next point you will notice there is a shortage of charge carriers occurs due to this diffusion process. What happens? Shortage of charge carriers. Okay, carriers. Spelling is wrong, right? Carriers. Okay. Shortage of charge carriers happens. So due to this shortage, a layer will form in between. That in next step I will draw and show. What will happen in the PN junction diode? Here P, here N, here holes, here electrons. Okay. After diffusion, a layer will create here. Due to the shortage of electrons, a layer will create here. And this layer, it is known as depletion layer. Okay, what does it name? That name is important. Okay, depletion layer. This layer forms due to the shortage of charge carriers. It will move like this. There will form a layer. Okay, depletion layer. Now, here arises due to this movement of electrons to here and diffusion. Here happens, here rises plus charge. Ions, positive and negative ions will form there. Here plus will form, here negative will form. Okay, fine. So next point you have to note what will happen there. Formation of positive and negative ions will be there. Okay. And due to this ions formation, here an electric field will be like this, from plus to minus, right? A field will form, electric field formation will be there, and here a potential difference will create in between. Here potential difference will form in between this layer. And it is that term you remember, there happens a potential barrier. Okay, it is known as what? Potential barrier will create. That is, after that potential, due to that potential difference, a potential barrier will come. That will, it opposes the movement of electrons. Further movement of electrons will oppose. Fine. That is, the potential barrier opposes the movement of electrons. Fine. This much things point you can note down while studying the PN junction diode. So first happens diffusion. Electrons diffuses to holes. Then there happens shortage of charge carriers, which will create a depletion layer there, and will arise a positive and negative charge on this both sides of the junction, and will form an electric field towards this direction, and a potential difference arises between this one, and it will cause a potential barrier which opposes the flow of electrons. Okay, now next thing here, we can connect this PN junction diode to an external battery. That process, it is known as biasing. That is next important topic coming in this PN junction diode. That is, biasing are of two types, forward biasing and reverse biasing. Where forward biasing, it is called the true connection. I will just give a brief definition on what is forward biasing and reverse biasing. In detail we can take in next video. Okay, that is, in forward biasing means if we connect the P junction, P part to positive and N part to negative, plus minus. Plus sign of the battery, we are connecting the P type, and if N type, it is connecting to negative terminal, then such connection, it is known as forward biasing. Okay, and it is known as the true connection. Whereas in reverse biasing, the P type, it is connected to negative terminal of the battery, and the N type, it is connected to positive terminal of the battery, which becomes the reverse biasing, and it is known as a false connection. Okay, so this topic is really important, and next video we can continue about forward biasing and reverse biasing. Hope the PN junction diode and what is happening, these key points you remember, you can expand the point. Okay, next video we can continue. Till then, bye.